Hello everyone, and welcome to the eighth lecture of the Introduction to Media Engineering course. So in this lecture, we're going to continue the topic of video and animation that we started last time. We are going to continue the topic of video, meaning that talking about live video, and then next we will move to the topic of animation. So in this part, we talk about editing and post-production. So if you have a video and you already recorded it, then you might need to edit that video. So video editing is the process of constructing a complete movie from a set of video clips or scenes, combining them with sound where required. So this is like an example of Movie Shop. This is like one software that allows the editing of videos. What you see here in this, like this is the video, and here what you see here is like this is the frame from one time point, and this is the previous frame, this is the previous frame. Now storing the video as a number of successive frames allows you to see and be able to control every single frame that you have in the video. And this is all, of course, because of our ability to store videos in a digital form. Okay. So that was editing. How about post-production? So post-production is concerned with making changes or compositing the material using operations that are similar to bitmap image manipulation. So editing, you're gonna combine a number of frames to make a video, while post-production, you are trying to process or change a little bit how the frames look like. So traditional films, if we go back to history and see how the traditional films that made movies, how they are actually edited. So traditional films used to be edited by physically cutting frames from the film and splice them together to compose a scene. This is like one image that shows one person, like an editor of a film. Now you see the negative of the film, that you have a number of images, like number of frames. So if you'd like to remove part of the film and attach others together, so what that person would do is that using scissors, he will cut the unnecessary frames and then attach one more time the remaining part of the negative to form a movie. Okay, why? Because in that film, every it's like a sequence of images where each image like represents a frame, the same way we do it in digital video. Okay. So if we check the effects that can be done in digital video compared to traditional films, so effects such as the dissolves and wipes are more complicated to do in traditional films. Dissolves is like if you have like two different scenes and one scene would disappear gradually while the other one will start to appear. This is what a dissolve. A wipe is a similar thing. So how can we do that in traditional films so that we can appreciate what we have now in digital form? So to do like things like this in traditional films, they require the use of a device called an optical printer. So what's an optical printer? It's a device that uses two projectors, each projecting the films that are to be dissolved onto a camera. Filters are used for each projector to control the dissolve effect. So let me try to draw this here so that to give you an idea. So this is like as if you have this. This is one projector. This is another projector, and here we have a camera. Okay, so this is projector number 1 called P1. This is projector number 2 called P2. C here refers to the camera. So what will happen is that projector number 1 will project its film here on the camera. Projector number 2 will do the same thing. So both of them are projected onto the same camera. But the thing is, they put here something like a filter and the filter here. And these filters, they move them at the same time. So how? Let me show you how this is done. Okay. So let me erase the filter of projector 2. So now, if this is the case, because the filter is completely obstructing the output that's coming from projector number 1, then the camera will be recording the output of projector number 2 only. Okay. Now, what will happen is that the filter, if this is the filter of projector number 2, this thing will start to move slightly, like going smoothly to cover the image that is coming out from projector number 2. At the same time, the image of projector number 1 will start to be projected fully. So this is also like the filter is leaving in that direction, while here the filter is moving actually in that direction. So if this is done like simultaneously, while you move in the filter projector 2, you're actually moving out the filter projector 1, and both are projecting in the direction of the camera, then what will happen is that the camera will get the feeling of the dissolve that happens between the two films. Okay, this is how actually the device looks like. So it's a huge device that can do this very simple effect, like one scene disappearing, the other one is appearing gradually. Okay. So now, how can we do that in digital video? So digital video editing made editing much easier, similar to how typing in a word processor on a computer is compared to using a typewriter. You can imagine the difficulties or the challenges of writing on a typewriter by putting a paper and the mechanical machine that you have now. The way we write text is very simple when it comes to writing using word processors on computers. Okay. Now, during editing, the clips are imported. When we talk about digital video, they are imported, trimmed, and assembled on a timeline. Like this is here the dissolve effect that I was talking about. So this is like a beach scene, and there is one person who's on the beach. If you would like to mix these two things gradually, like this scene will start to disappear slowly. You see here the character starts to appear, and then that scene will get stronger while the other one will fade away. So how can that be done in digital form? It's very, very actually simple. It's like this would be the outside of the house scene, the frames of the outside of the house, and this is here represents the frames of the figure by the sea. And then you can do that in the software by saying, okay, I would like to have a dissolve starting from this time point until this time point. So if this scene of outside the house ends here, the figure by the sea starts here, you want the dissolve from the moment that the figure by the sea appears until the outside of the house disappears. And this can be done by a very simple function of mixing the frames. Okay, so now this is a very although it was very difficult to do in traditional films, that you need that optical printer device. Now when it comes to digital video, it's much easier to do, as you can see here. The other advantage of using digital video for editing is that the edited digital video can be played back as soon as it's edited, not like how it used to be with traditional films, because as we said, in traditional films they have to splice them with scissors. Of course, you can imagine that using scissors to cut films might cause problems and you might lose frames in that process. In addition, after you do the cutting, you have to attach them and then prepare them in some way to be played. However, you can do editing for digital video, and the good thing is if you don't like it, you can go back. You can always undo what you did. While in traditional films, there is no way you can undo it. Once it's cut, then it's gone forever. So that's one of the advantages of using digital video representation for editing, is that things are much easier. You can avoid losing any information that might go away during the editing process. And of course, it can be played back as soon as done. You can just do the editing and click play, you see the video. There is no preparation that's needed. Okay. In post-production, the values of effects parameters may vary over time. This is one thing also that's possible in digital frames, like you can play with the colors of each frame individually, which is something would have been very hard to do in traditional films. Okay. So this is all about editing and post-production. Now, the next thing that we would like to discuss here in the video topic is video delivery, because right now we can always watch video over the internet. So how would the video be delivered over a network? This is one important topic to discuss. So video may be delivered over a network as a downloaded file. It may be streamed, or it may be delivered by progressive download. So these are three different ways of delivering video. Either you download the video and you have the video file on your computer and you can run it, or it may be streamed. And by streaming, it means that you wouldn't have a copy of that video on your machine. Okay? Or it may be delivered by what's called progressive download. So what do we mean by both? So there is something called embedded video. Embedded video is that the video is transferred from a server to the user's machine and not played back until the entire file has arrived. So the video will be sent to you from the server. Still, you wouldn't have access to that video file, but then once the whole video is downloaded, it starts to play back. The progressive download, which is also called HTTP streaming, this is different. The file starts playing as soon as enough of it has arrived. So if you're watching a video on YouTube, for example, you see like there is always that bar that shows how much of the video you have received. However, in order to play the video, or in order for the video to start playing, you don't have to wait until the whole video is actually has already arrived to your machine, right? You'll find that the red bar will go until a certain some point, and then the video starts playing, and then it will continue downloading during the same time that your video is playing. So this is what we mean by progressive download, and this is what's used by most of the platforms that are available online for playing videos and uploading videos. Okay. In true streaming, as I said, the video is never stored on the user's disk, but it does require sufficient bandwidth to deliver frames fast enough to be played. So by true streaming here, we mean that you get the frame, you play it right away. You do not you wouldn't have a buffer of a number of frames that have to be delivered in order for the video to start to playing. Okay, so this is what's called true streaming. Like you get a frame is sent, you play it. A frame is sent, is played. Now, for this to happen, then as we said, you have to have sufficient bandwidth for the delivery to happen fast enough to be played. Otherwise, you will miss some of the frames. The progressive download is like a compromise between the embedded video and the true streaming, because true streaming, you get the frame you played, nothing is stored. Embedded, the whole video has to be transferred before it starts to play. Progressive download is a compromise, which is that the file starts playing as soon as enough of it has arrived. We will talk in the next slide about this enough, what would be considered enough. However, this is the difference between true streaming, embedded video, and progressive download. So let's have this example about progressive download. Let's assume that we have a 30-second movie, so a movie that's 30 seconds long, okay? And that has been compressed to a data rate of 2 megabits per second. So what do we mean by this? We will talk about compression later on, but let's talk about this. This means when you say that you are compressing a video or a movie to a data rate of 2 megabits per second, this means that every second of the movie is saved in 2 megabits. And again, when we talk about bits, megabits would be just 1 million, not the 1024 by 1024. So this is like 2 million bits. So every second of the video is stored in 2 million bits. Now, if the movie is to be sent over a connection that operates at a speed of 512 kilobits per second. So every second, your machine will receive 512 kilobits. Okay. So if we multiply these numbers by each other to see how much time we need to receive the video is 30 seconds, right? Every second is stored in 2 megabits. Now we divide that by the 512 kilobits per second that we can receive, okay? So what we get is 120 seconds, okay? So if every second we receive 512, how many kilobits are we expecting to receive? It's 30 seconds by 2 megabits. So therefore, this video, in order to be downloaded fully, you need 120 seconds. Now, we said in the progressive download is that the video will start playing as soon as you have enough data for the video to start. So what do we mean by enough data here? So one way to identify what would be enough data is that once the video starts playing, it should play until its end without stopping in the middle, waiting for another part of the video to appear. So this is what we consider to be good enough. So let's say you have your video 120 seconds. It will take 120 seconds to download. So we would like to know at what time point this video should start to play, such that if it starts playing, it will play fully until the end without actually being interrupted, or without actually needing to stop or pause for other parts of the video to appear. So let me explain this a little bit here. So let me draw this. We actually usually represent this graphically. Okay, this is here time on the x-axis, and here this is the percentage of the frames. So as we computed here, we need 120 seconds for this video to be delivered, right? So if we imagine if this is time 0 and this is time 120, then at 120 we will have 100% of the video delivered, and the process goes through a straight line like this. So starting from time 0 until time 120, we should receive the whole video. Now the question is, at what time point here along the x-axis between 0 and 120 should we start the video such that if it starts, it runs till the end without stopping for the need for other part of the video to arrive. Now, if you think about this, now given that the movie is 30 seconds long, okay, then one can easily conclude that if we start this video at time 90, okay, after 90 seconds of the beginning of the download, given that this video will take 30 seconds, the whole video is 30 seconds, right? So if you click play, it should run for 30 seconds. So if you start this at the time 90, then actually, let me use another color here. This line is the line that represents the playing of the video, the blue one, while the red one represents the line of delivering the video. So this is the download line and this is the play line. As you can see here, at time 90, if the video starts playing, because the video is 30 seconds long, then it will end at 120, which is at the same time moment that the whole video would have been downloaded. Okay, so given that this line and this line, they meet at this point, which is meaning that these two lines are not intersecting, then actually this means that this video will run starting from point 90, it will end at point or at time 120, and then without being interrupted. If you think about, okay, what if someone says, I will start playing that video at time 30 seconds, okay? So if this point here is 30 seconds, if the video starts playing here, then the whole video should end at time 60, right? So if this is 60, or actually let me erase this and do this idea that I was discussing on the other graph. Okay, so again, this is actually the same thing here. So the video, as you can see, it takes from time 0 to 120. So this is the percentage of frames received at 120. 100% of the frames would have been received. If we start playing at time 90, this video will run all the way until its end without being interrupted. Now, what if someone decides to start playing the video at time 30, which is this point here? Now, given that the video is 30 seconds long, then if we imagine that this video will start playing at time 30, then it should actually reach 100% at 60. So that would be the line connecting these 2 points. Now, as you can see, this line I just drawn in red, it's actually intersecting with the frames received. Now, as you can see, they are intersecting at this point. This means that at this point, part of the video would have been played, but then the video will stop. Why? Because as you can see here, if we check this point here on the y-axis, let's assume this number is 27. I'm just making an assumption. Not sure what exactly the value is, but this is like 27%. So this means at this time point, 27% of the frames are received and 27% of the frames are played. Okay? Now, right after this, you should play the next frame. However, the next frame wouldn't have been received because, as you can see, it takes actually longer time for the video to arrive or to get downloaded than it gets played. Okay, so once you reach this point here, what will happen is that the video will pause, okay, because you played all the frames that you have received, and then you have to wait for a little bit more time. So in that case, the frames received would be something like this, or sorry, the frames played, you'll have to stop the play for some time. You go like constant until you receive enough frames so that you can start playing one more time, and so on. Okay, so this is the whole idea about progressive download. So as we said in the original example, after 90 seconds, 3/4 of the frames will have been received. So if the movie starts playing at that point, by the time 30 seconds are done, the rest of the movie would arrive. Okay, so this is why when you click on a video on YouTube, it starts to download some stuff, but doesn't play right away. It actually does some computations trying to estimate the download speed that you have in order to determine when to start playing your video. Okay, so this is all about video delivery. The last thing that we would like to discuss here in the topic of video before moving to animation is what's called multimedia architecture. A multimedia architecture provides a number of things: an API, application programming interface, for capturing, playing back, and compressing videos. Okay, so this is like a framework that tells us how we can capture a video, how we should play it back, and how we can compress it. And also, a multimedia architecture will have a container format for storing media data, which is how are you going to store your data. A streaming server that is going to stream or transmit the data, and software tools such as player or editor. All of these things make what is called a multimedia architecture. So QuickTime, for example, is the multimedia architecture that's used by Mac OS. DirectShow is the multimedia architecture that's used in Windows. The file formats that we talk about here, for QuickTime it's MOV, and for Windows it's like Windows Media Player Video, or WMV. Okay, there's also Flash Video, which is widely used for web video. FLV, this is the extension. The FLV files must be played in the Flash player that has SWF that controls the video playback, or in third-party player. Okay, so this is all about the video topic. Okay, so now we move to the next part, which is talking about animation. So after we finish talking about video, we next move to animation. Okay, so what is animation? Animation is the creation of moving pictures one frame at a time. And mostly this is created actually on a computer. So in order to see how animation is started, we have to go back and see the process of animation starting from traditional animators, how animations were actually created in the beginning in traditional ways before going to the digital one. So traditional animators have developed many techniques, including cell animation, stop motion, and claymation. Let's see actually as an example, this actually here video about how we can actually create an animation using here, just a second. Okay, how we can create actually an animation like things like Disney animations, for example. So let's see this video. So this video will show you the process of animation, how they used to create animation back in the old days when this whole thing has started. And then we will see how we can do that in a video, or in digital, animation. So first they start with the concept. They have to explain what is the concept, and from the concept of like Snow White, for example, or Mickey Mouse, or so on, then they do what's called a storyboard and inspirational art. They start drawing the main characters that would appear in the movie. Okay. Once they draw how the main characters look like, they start drawing the main scenes that will appear in the video. Okay. So these are like the main scenes that should appear. This is like the storyboard. Once they do this, the general idea, they do the voice recording. So the voice recording is done before actually creating the whole animation, because it's much easier actually to draw based on how people speak. And then they start drawing. This is like they actually draw it frame by frame. So every video animation that you see, like Snow White, Mickey Mouse, and so on, back in the days, the old ones like Tom and Jerry, they were created frame by frame. Okay, by animators, people who are artists that go and draw each single frame. Okay, once this is done, they start the inking process, like coloring inks on actually transparencies, as you can see, and then they paint those transparencies with color. So this is transparent. Why they use transparencies? In order to insert backgrounds later on. So they draw the backgrounds, artists draw the backgrounds, and then these slides are put, and then they start photographing them. Okay, so they bring a camera and photograph frame by frame, okay, those transparencies on top of the backgrounds. Okay, they photograph them, and then they create a motion picture by stitching together those single frames. This is how actually video or animation is created, like in Disney things. Okay, so you can see like this process is very complicated. Like you see how many people are actually involved in it. This is one thing. The other thing is how they are actually created. Like you see, like people draw the main frames. People like they start drawing the in between frames, like the single motions. Every single frame has to be drawn, connected together somehow, and photographed using a camera. It's like a very long process. Okay. Okay, so the next thing is that animation made using any of the traditional techniques can be captured one frame at a time, as we explained, using a camera. Now, if you would like to go into digital animation, you can use the same process, but then the camera can be connected to a computer instead of being recorded on the film. The idea of combining actually a traditional animation with digital form, this is what we call hybrid animation. Let's see an example here. So I'm gonna show you here a video of a hybrid animation, something that has something captured with the camera along with a mix with something that was created digitally. So here they have a camera, they picture that person moving his arm, and then at the same time you can see there are some drawings that appear. So these drawings could have been actually captured also or drawn in a traditional way, or they actually could be drawn on the computer itself. Like you see this effect, this is a digital effect. Okay, this is all a digital thing. So here we are combining digital information with analog actually information in that case. Okay. So this is what's called hybrid animation. So now with the development of digital animation, we can actually combine these two things together. And this is what you see now in movies. You have some digital stuff and some analog stuff. Like by analog here, I mean a live video thing that has been taken. Okay. Okay, so now given that we have images, when we talk about digital animation, we have images stored in the form of image sequences. Then animations can be created digitally by playing back those sequences or those frames very quickly. Individual frames can be actually created in a graphics program. You can actually do it in Photoshop and whatever tool. You can create every individual frame if you want on the computer and then play them back very quickly. Now the concept of layers that we talked about when we talked about digital still images can still be used here. Using layers to represent the content of a frame can actually streamline the animation process. So for example, you see this example here. We can think of the background here, the beach thing, as a layer, and then we have another layer that represents that boat. Now if this is frame number 1, this is frame number 2, this is frame number 3, and these frames are played back very quickly, you will get the impression that the boat, which is a single layer here, has been moving like from this point to the right until reaching that point. Okay, so this is the animation of layers position, like the position of that layer, the boat in that case, will determine how actually uh, uh, the boat will appear to be moving along the horizontal x-axis here. So the creation of the animation digitally actually allows effects such as rotoscoping, which we are going to discuss here. So what is rotoscoping? Rotoscoping is tracing selected elements from a live action video clip onto a new layer, one frame at a time. Let me show you this video that will explain the idea. So in this video, we will see how a video can be created actually artificially, as you will see, despite that it might seem very true or natural. Okay, so let's see this. So there is a train coming. See, this guy is crossing the railroad. He's almost like got killed. Okay, now that video that you just saw was a fake video actually. So this is how it was done. Okay, so there is a video that was actually captured for the train coming by without the guy wasn't crossing or anything here. Okay, and then after the train has passed, you will see here the guy is actually doing the same movement that you saw in the first video. Okay, so the whole idea here is that these are two different videos, and the way that this person has created that video, that he was tracing the two videos frame by frame. Okay, so he had the first video, he has the second video, and then frame by frame he's trying to synchronize the second video to the first video. And this is what you see here. Of course, it takes a very long time to do, but it's actually doable. Okay, the good thing here is that this is only possible because the two videos, the first one and the second one, they have the same background. The background is not changing, so it's very easy to create a layer of the person in the second video, and then make it like as if he's crossing the railroad. Okay. So this is the idea of rotoscoping, and this is all possible because we now have videos that are stored digitally, like in a digital form. So it's easy to do this process by synchronizing or aligning the frames together. Okay. One more thing about image sequences, that the sequence of image can be stored in consecutively numbered image files, which can be then imported into video editing programs or Flash to create animation. Okay, now something else related to animation is the animated GIFs. So an animated GIF contains multiple bitmapped images in a single file, like you see here. This is 1, 2, 3, 4 frames that are actually this is the original top and animated GIF bottom frames, suitable materials. So like you can actually take these images and then play them back very quickly, like you do this one, then this one, then this one, this one, and play them back over and over and over. It will appear as if the dolphin is like keeps jumping up, down, and so on. So an animated GIF actually contains multiple bitmapped images in a single file. The individual images can be displayed in sequence by web browsers and any other program without the need for a plugin. Like to play a GIF, you don't actually need something that would be installed on your computer to be able to play it. Okay? Why? Because it's just a sequence of 3 or 4 frames that are played back. Of course, animated GIFs or GIFs in general, they are stored using indexed image, as we explained before. So every single frame that you would have would be stored as an indexed image. So these animated GIFs are only suitable, of course, for short and simple animations. It's not possible to make a video in this way, of course. Animated GIFs, they use index color, as I said, and also lossless intra-frame compression. This is something that we are going to discuss later in the compression topic. And of course, the effectiveness of these two things depend on the nature of the images in the animation. Like as we said before, for an indexed image to have a smaller size than a traditional image representation, you have to have repeated colors, otherwise it will actually be wasting space in that case. Okay, so so this is what we mean by the effectiveness that depends on the nature of the images. One more thing about animated GIFs, although they have a lot of advantages, is that they cannot have a soundtrack or player controls. So when you play a GIF, it's always silent. Of course, it doesn't have audio component attached to it. Now, something that's really important when it comes to making animation is the concept of interpolation. So what's the concept of interpolation? So first of all, in traditional cell animation, you know, like this is the Disney type animation that was created back last century in an analog form, as we explained in the beginning of this part. The chief animators, they draw keyframes at important points in the animation, and then there are other type of animators, other artists that are called in-betweeners. And they are called in-betweeners because they draw the in-between frames. So they create the intervening frames. So for example, the chief animator will draw, like you see this example, will draw this one. This is keyframe number 1, and we'll draw this one as keyframe number 3. And then the in-between will be done or created by the in-betweener, who will draw all of these frames, trying to imagine for this person to be here or to have this position in this keyframe and to have the other position in the other keyframe. What should happen in between? Like this book, for example, has to transfer from this hand to the other one. Okay, so the in-betweener will do this process. Like in between, this book will transfer, and while the moving will look natural, like by this leg keeps moving forward, the other one gets backward and then back again. Okay, you can have actually multiple keyframes, like this is keyframe number 2, this is keyframe number 3, and the in-between will draw all of the ones in between. So the chief animators draw the keyframes, and the in-betweeners create the intervening frames. Of course, this is very tedious and it takes a lot of time to be able to do, right? Now, in the digital animation, the animation programs can perform the equivalent of in-betweening by just interpolating the values of properties such as position between keyframes. Actually, they would have a software component that will do this process. You give it the keyframe number 1, keyframe number 3, and it will then do that in-betweening thing, like drawing all of the ones in the middle. So let's see some examples of this process. So as an example, let's talk about motion interpolation. So what is motion interpolation? It's creating frames that represent the motion of an object given a number of keyframes. So if you see this example, let's say we have this layer number 2, right? And this is actually layer number 1, okay? Now let's assume this is keyframe number 1, where you have the boat in this position, and keyframe number 2, you have the boat in this position, okay? If this was a traditional animation, then someone needs to draw, if let's assume that the boat will move from this point to this point, as it appears here. So the in-betweeners will have to draw every single move that this boat will make going from this point to this point, okay? Now, to do this, it's much easier to do it here. For example, these slides were created using PowerPoint. And in PowerPoint, you can just create a layer that represents the boat, create a layer that represents the background, put the boat in the first point, and then you can actually, what you easily do this, you can draw with an arrow using the animation property that you have in PowerPoint. You draw with an arrow, you say that I have an animation of motion along that line, and then by using a code that runs in the background, of course, that boat will move from this point to the other point, okay? So this is what happens, as you can see it here. You see that the boat has actually moved from this point to this point, okay? So since bitmaps do not contain identifiable objects, the use of layers to isolate different elements is essential for interpolation. As I explained, you would have a layer for the boat, a layer for the background, and then layers of a bitmap can be moved independently of each other, as we saw here that the boat moved from this point to this point, okay? So this is the use of interpolation to create animation. Now it's very simple, it's just a simple function. Imagine the effort that had to be done in the traditional animation, that someone has to draw every single frame that represents the movement of the boat. Now with digital animation, it's much simpler to do, okay? So if we can imagine the process that we saw in the previous slide, let's assume on the x-axis we will have the keyframe. So this is keyframe number 1, this is keyframe number 2, where this is keyframe number 1, where the boat was here, and let's assume keyframe number 2, for example, the boat is in another position, okay? So we're plotting here the displacement of the boat versus the keyframe, and here the velocity of the boat versus the keyframe, okay? So if you assume that at keyframe number 1 the displacement was 0, at keyframe number 2 the displacement is another value, let's say 5. In between, the boat is moving along this line, so this is like linear, kind of linear interpolation. If you think about the velocity of the boat in that case, so at keyframe number 1 the velocity will start to be 1, and then the velocity is constant. Why? Because as you can see here in the displacement here is increasing with a fixed rate, okay? So with a constant velocity of 1, the keyframe will go from this point to this point. Once it reaches keyframe number 2, the velocity goes down to 0. So which means that now the boat is not moving anymore. So it's just moving from this point to this point in keyframe number 2, and then it stops. So that's why the velocity goes down to 0. Now, if motion is interpolated linearly, movement begins and ends instantaneously, and there may be unnatural discontinuities between interpolated sequences. What do you mean by this? If you imagine how that movement would look like if the boat starts from keyframe number 1 and moves to that position in keyframe number 2, if the velocity was constant equal to 1 and then suddenly drops to 0, you can imagine that this is like the boat is moving and then suddenly it stops. Of course, this is not natural, because anything when it stops, it first decelerates. Like for example, the velocity will keep decreasing until it comes to full stop. Same thing here. Nothing actually moves from 0 to 1 suddenly. You have to have gradual change in the velocity from 0 velocity to 1. So that's why we're saying that if interpolation is done linearly, like here and here, the movement will begin and end instantaneously, and it wouldn't look natural. So even that, we have a solution for this that we will see in the next slide. So to make actually the movements look more natural, we can use what's called easing in and easing out, which can be used to cause the motion to increase or decrease gradually. Like if you look at this, these two examples. So here we have keyframe number 1, keyframe number 2. This line is what we saw in the previous slide. Now what we will do is that we will change the way the boat moves from between keyframe 1 and 2 by making the velocity, as you can see here. What you see here is that the velocity is starting from 0 and then it gradually increases until it reaches that point and then drops back. So this is like if you imagine in terms of displacement. So initially your speed is very low, so the change in displacement is very small, and then the speed starts to increase. You see the displacement change starts to be higher and higher because the velocity is increasing. It's not a constant velocity, it's a velocity that keeps increasing until it reaches that point. Okay, so this is called easing in. Okay, now this is called easing out, where you see keyframe number 1, keyframe number 2. You start with a high velocity and then the velocity keeps decreasing until it reaches 0. See here the displacement is actually saturating until you reach. So this will give you the effect that something is coming to a full stop, but not actually suddenly. It's actually a gradual change until it comes to a stop, and this is a gradual change in terms of increasing the velocity. All of this can be done very easily in digital animation, compared of course to if you were doing this, for example, in natural animation. It wouldn't be that easy. It would have to be done actually in it would need a lot of effort from the in-betweeners to do all of that imagination, because they do not use actually mathematical equations to draw this curve or this curve. Okay. They rely on how they imagine things and draw them. So the ability to get things that look natural would be much higher to do in digital animation compared to the traditional animation that we talked about in the beginning of this part. The other issue with linear interpolation is that it can cause other problems, such as when 3 keyframes exist in a scene with linear interpolation in between. So for example, let's imagine we have keyframe 1, keyframe 2, and keyframe 3. If between keyframe 1 and 2 we have a constant velocity of 1, and between 2 and 3 it's 0.5, you can imagine that from keyframe 1 to keyframe 2 we have a certain velocity, and then suddenly it changes, so the displacement will get actually less in that case. That would also make things not natural. You need some like non-linear actually change from one velocity level to the next one. So custom easing, like easing the velocity, this could be done using actually Bezier curves, which are used to control the rate of change in arbitrarily complex ways. So you can actually use a Bezier curve to go with a velocity, something like this, and then for example something else like this, and so on. Okay, so this is all about interpolation and why linear interpolation is not really preferred, while other forms of interpolation, things that are non-linear, would make things look more natural when it comes to the movement of objects. Okay. Another thing is that objects or layers can be actually made to move along motion paths. So for example, let's say we have this car and we would like it to look like as if it's moving up and then down, like as if it's going above a mountain and then going down. Now, one issue with this is that if you keep the orientation of the car fixed, as you can see here, this of course doesn't look natural. So you need the orientation to be something more like this. This looks natural. So when using motion paths, it's usually necessary to orient the moving object to the path to achieve a realistic effect, which is something that was done here actually. Again, all of that also is very easy to do in digital animation and would take a lot of effort to be done in the analog one or the traditional animation type. The other thing is that motion paths can be actually used to simulate effects such as a bouncing ball. So this is how it's actually done. If you have a scene like this and you would like to make this ball as if it's bouncing like this until it comes to full stop, This can be easily done by just drawing the path that the ball has to go over. Like if you see this is an example created in PowerPoint. See that the ball is actually, this is a very simple explanation of how it could be done actually. We next talk about vector animation in Flash. So by vector animation here, we're meaning that we are actually creating the animation using vector graphics. So Flash movies, also known as SW files, are the most popular web animation format. They are usually created in Flash, but SWFs may be also exported from other programs. An animation being created in Flash is organized using a timeline. This is the timeline that you see here. And you will have the object that is supposed to move. Keyframes in case of vector animation are drawn in their entirety on the stage. So on that software, ordinary frames have no content. They just hold the picture from the preceding keyframe. Graphical objects can be stored in a library as symbols. Like for example, you see this. These are all instances of the same symbol, whatever this creature is. Okay. And instance of symbols can be created on the stage, allowing the objects to be actually reused. So you can have multiple objects as you saw here. They also use the concept of interpolation, which is called tweening, is applied to symbol instances. Like for example, if you would like to make this object appear as if it's like going through that scene, going from the left to the right, again, you can create keyframes and then do interpolation. And object size, orientation, opacity, and color may also be interpolated if needed. There are actually three sorts of symbols in Flash. There are graphic symbols that are reusable vector objects, like that object that we saw in the previous slide. There is also the movie clip symbols. These are self-contained animations with their own timeline that play within the movie and can be controlled by scripts. So these are like movies that play within movies, okay? And there is also the button symbols for interaction, like something button that if you click on, something happens and you get some code would run in that case. There is also another thing other than Flash is motion graphics, and motion graphics is animated graphic design, which is like, for example, if you would like to make a count of 5, 4, 3, 2, 1 until 0, things can be done very simply by, like the 5 is static here, but these red lines, they're actually moving to the left and they are fading out, and then they appear again and then they appear in a different way. These are simple motion graphics. Again, things are created on the computer, and then interpolation may be used to control the rate of change of properties as well as their values, like the rate of change of the color or the transparency of the red color that we have here. Last thing here is delivering animation. The three predominant formats for delivering digital animation are the animated GIF, the Flash, the SWF, and video. Of course, video must be used for animation that will be played on a television. If you're ever going to play animation on TV, in that case, video format has to be used. If animation is delivered as video, a soundtrack can be added, and player controls can be used, and high compression can be achieved using modern video codecs. So these are multiple things that you will need for video, soundtrack. You need player controls like play, forward, fast forward, backward, pause, and so on. And also you need high compression, as we said before, because if animation is represented as a video, it will be actually represented as multiple frames. Each frame is like a bitmap frame, and that will take a lot of storage. Also, Flash is superior for vector animations because by nature Flash is a vector graphics platform. For bitmapped animations, animated GIFs may be used without a plugin, as we said before. But of course, it wouldn't provide the best quality. Video, of course, will provide the best quality. Finally, the Flash movie file format is a compressed binary format that provides an efficient way to deliver animation over a network, as we explained, because it relies on vector graphics. Okay? Alright, so that's it. One more note I would like to make here. So the video of rotoscoping that I showed in this video, the guy who was crossing the railroad thing, please do not try this, okay? Because I know that some of you might be motivated to create a video similar to it. Please do not do it, okay? You wouldn't want to lose your life because of something like that. So this is just an important note that I forgot to mention when I talked about rotoscoping. All right, that's it. This concludes the topic of video and animation, um, which we covered in the last two lectures. Okay. All right. Thank you, and I'll talk to you soon.